Alright guys, so problem number 8. We have an object is thrown from the top of a 100-foot tall building. The graph represents this situation as shown to the right. Answer each question below this situation. So we have maximum height of the object was about blank feet. So maximum height, this, like I said, most of this test will be kind of pretty straightforward, something like this. So the height of the ball, or the height of the object, you kind of follow it. Obviously the maximum will be somewhere right there. And if I just trace it right back to the feet, again, not rocket science, looks like it's going to be 125 feet. The object was in the air for blank seconds. So you basically, so your seconds, so this is just kind of tick, 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 it's going, right? So if I just kind of look at the ball, it's flying, it's flying, it's flying. Finally, it gets to 0. Remember that 0, a height of 0, that's your ground. So if you just kind of want to picture it like this, so there's your building. The ball gets thrown from the building, and then eventually it hits the ground. Right, so it looks like it's in the air for 16 seconds. The object was at 100 feet at about blank and blank seconds. So since it's a parabola, it will be at a certain height sometimes twice. So for example, this, we're looking at 100 feet. So basically, right at 100, I just draw a horizontal line going straight across. So there's my line. And whenever it asks me at what point was it at 100 feet, I basically just trace it down. So I trace it down, so at 0 seconds, obviously we started at the top of a 100-foot tall building. And also, so I threw it up, and it came back down, and after 10 seconds, it was also at the same height of 100 feet. So this will be 0 seconds and 10 seconds. What does the point 10, 100 mean in this situation? Write a complete sentence. So 10, 100 is this point right there. So basically it's asking me, what does that point mean in the situation? So what does that point mean in regards to an object is thrown from the top of a 100-foot tall building? The graph represents the situation as shown to the right. Answer each question about the situation below. Right. So basically just this, it's thrown from the top of a 100-foot tall building. So that basically means that I take the object, I throw it, it reaches its maximum height, and it starts coming back down, and it gets to 100 feet at 10 seconds. So this is basically, we can go ahead and write this as the object returns to 100 feet at 10 seconds. Right? Nice, short, simple. The object returns back to the height of 100 feet at 10 seconds. So it's returning to the same height. Complete statement from the graph. Complete the statement from the graph. Blank depends on blank. So basically, which one is your independent, which one is your dependent variable. So your independent is pretty easy to figure out. Your independent is always your x value. So this is always independent. And so my y value is my dependent. And here's why. So the reason that your x value is your independent is because time does not care if you're having fun or if you're studying for your Algebra 1 test. Time still keeps going, right? A minute's still a minute, an hour's still an hour. Your time does not depend on anything else. However, the height of your ball depends on how many seconds have passed. Right? At 6 seconds, it's not going to be at a random point. At 6 seconds, it's going to be right exactly where it needs to be. At 10 seconds, it's not going to be at a random point wherever it decides to be at the time. It's going to be right where it needs to be. Right? So it depends on the time. So we're going to go ahead and say height depends on time. So again, this is my independent and my dependent. So my height depends on my time. Flip it over to the back. We're almost done. Write the equations of the two graphs shown below, given that the coefficients are 1. So the big part here is that the coefficient is 1. So that basically means that we have y equals 1, x minus h, parentheses, plus k. And the equation that I'm using again is my vertex form. My vertex form is again y equals a x minus h squared plus k. So it basically tells me that my coefficient is 1, or in other words, my a value is 1. So what I'm going to do is I'm going to take my equation, and I'm going to figure out my vertex for the 2, plug it in for h and k. Remember that your vertex form is called vertex form because your vertex is always going to be at h comma k. And h being h and k. So remember that x minus is part of your equation. X minus and then h plus k. Alright, so we start with, let's go ahead and start with our very first one, or the one at the very top. So there's my vertex. Looks like my vertex is at the point 0, 5. So my first vertex, we'll call that V1, is at 0, 5. So with that, what I basically do is I take that and I plug it in. So this will be my h, this will be my k. So my first equation is going to be y equals 1 x minus 0 for my h squared plus k, or plus k plus 5. Alright, so there's my first equation. I can kind of clean this up a little bit. X minus 0 is just going to be x, so really this is just going to turn into x squared, 1x squared, or in other words just x squared. So my equation becomes y equals x squared plus 5. So there's my first equation. My second equation and my second vertex, so this time my vertex is at, looks like 0, call that V2. My vertex is at 0, comma, negative 6. So once again, I take my values and I plug them in. So my second equation is going to be y equals 1, x minus, once again I have 0, squared, minus 6. So this time my k value is negative 6. So again, that's my h and k. Once again, I can kind of start cleaning this up. X minus 0 is just going to be x. So I can write that as 1x squared, or in other words, just kind of really clean it up. Y equals x squared minus 6. So those should be my two equations. Once again, you never want to, I don't want to say don't trust yourself, but always make sure that you double check on your calculator. It takes literally seconds. So we have x squared plus 5. And we also have x squared minus 6. I go ahead and hit graph, and my graphs should match. So as I look at my graphs, now obviously they're not going to match exactly, but I just want to look at my vertex. So my vertex is at 0, 5, and our vertex is at 0, negative 6. So those match with that picture. So that's going to be one of my equations. That's my other equation. Number 10. Write an equation of a function that would appear to be shifted 3 units up from the graph of f of x equals x squared plus 9. So with something like this, we want to shift our parabola up 3 units, or 3 units up. So we basically have to go back to our vertex form. Vertex form, we have y equals a x minus h squared plus k. Remember that my value that controls up and down is going to be my k value. So this one controls up and down. This is left to right. Again, h is left to right. K is up and down. A controls either opening up or opening down. And it also controls the shape, so whether we're skinny or we're wide. Right? So that the A controls these 4 things. So basically the value that I'm looking at, or looking for, if I'm going to shift up, is going to be my k. So if I'm shifting up, I basically want to move up, or add 3 units to the end. So my equation, the a value is there, and I don't have one. My h value is in parentheses, and I don't have parentheses, so technically I don't have an h value. My k value is always what I add or subtract, so in this case it's plus 9. Well, if I want to shift 3 units up, that means I'm doing plus 3 units. So basically what I do is I just do plus 3 to the 9. So that right there would give me 12. And so my new equation would be f of x equals x squared plus 12. And it really is that easy. All you do is just add 3. Basically what you're doing is you just have to figure out what part of the equation you're adding 3 to. The quadratic function f of x equals 2x squared plus 4x minus 6 is shown on the graph. We have 3 different questions for this. The first one is, what are the zeros of f? So remember that zeros mean x-intercepts. So basically, what are the x-intercepts of f, or our function? So we have that and that. Alright, so my zeros, and again, you don't want to just write the values. I would highly encourage you guys to actually go in and write your points. So my point is going to be -3, 0 for this one, and for my other one it's going to be 1, 0. So those are my 2 points. What is my axis of symmetry? Well, for axis of symmetry, I need to figure out my vertex first. So I go down to my parabola, locate my vertex. My vertex is at the point, so we're going to go and say V is at the point -1, -8. My axis of symmetry is my x value of my vertex, so it's going to be x equals -1. And again, it's always x equals. Don't forget your x equals part. Finally, part C, for what values of x is the function equal to -6? So again, function equal to, so function, in other words, f of x equal to -6, or, again, remember that f of x also stands for y equals -6. So we're basically going to our y value, we're going to that -6, and we're going straight across. No problem. So if I go straight across, I see that my y value, or the x value where I equal -6, is going to be at 2 different points. And again, it's asking me for what x values it actually is. So my x value, my first x value, if I trace it up, it's going to be at 0. So we're going to go ahead and say x equals 0. And if I trace the second one up, it's going to be at -2. So we have these 2 values give me -6. Just really quickly, I want to show you guys how you can find it on your calculator. So if we go to our y equals, we clear and we clear. We write our equation, which is given to us up here. So we have 2x squared plus 4x minus 6. The second graph. I can figure out -6, where my function is equal to -6, or in other words, where my y is equal to -6. So if I scroll up, I see 2 -6s. Right on my y side, I see one there and one there. So those 2 values, I just basically trace it back over. My x value is -2, my x value is 0. So that's just another way that you can also find your x values for that. Alright, and then finally 12, hopefully YouTube lets me upload this video because it's already 12 minutes long. So we have John entered 3 functions into the graphing calculator and recorded the values from the tables as shown. Use the table to answer the following questions. So it says, what is the vertex of y2? So we basically have to know that each of these tables goes, so we always want to have one x and then one y. So this would be x, y1. Our second table would be x, y2. And our third table would be x, y3. So basically these 2 go together, and then these 2 go together, and then these 2 go together. So the x is always with them, right? I only have one x column, and then each one of these is my y value. Alright, so if we're looking at a vertex of 2, we basically don't need that, and we don't need that. And I wish I had something better to cover them up with. But we don't need y1, we're looking at y2. So my vertex for y2, I take my pencil, I cover those up, I start pairing them up. So it looks like -2 goes with -2. -5 goes with -5, and then I have the 6. And once again, if I cover up my y1 because I don't need that, I'm looking at only y2 and x. If I look at that point, then the x value that corresponds with that is going to be 0. So my vertex is going to be at 0, -6. Part B, what is the vertex of y3? So now I don't need that, and I also don't need that. I'm only looking at x and y3. So y3, once again, I can take my points, I can start pairing them up. So -8 with 8, negative 5 with 5. 0, even though it doesn't show up, I know would go with the other 0. So the point that's in the middle, or the point that doesn't have a pair in this case, is going to be 9. And that 9 is going to match up with the negative 1. So my vertex is going to be negative 1, comma, negative 9. Again, because I cover these up, my vertex is always xy. Right? We have an x value and we have a y value. Xy of negative 1, 9. Finally, what is the axis of symmetry of y1? So to figure out axis of symmetry of y1, we have to first figure out our vertex of y1. So again, 4 with 4, 1 with 1. My vertex looks like it's going to be at 0, 0. And it's the x value of my vertex, so x equals 0. And then finally, part D. The graph of y2 is shifted blank units below y1. So we just basically look at our values. We start comparing them across now. What's the difference from one value to the other? So 9 to 3. So 9 to 3, this 3 looks like it's minus 6. 4 to negative 2, once again looks like it's going to be minus 6. 1 to negative 5 looks like it's going to be minus 6, right? This is basically what the step that I'm doing. 9 minus 6 gives me 3. 4 minus 6 gives me negative 2. 1 minus 6 gives me negative 5. 0 minus 6 gives me negative 6, and then repeat. Right, so it looks like all I'm doing is just moving down 3. So the graph of y2 is shifted 6 units below y1. So basically, again, you just kind of figure out what your pattern is, what you're adding or subtracting from each one. And that's it. That's our review. Hope you guys score well and do well on your test. Until next time.